be asked to do, and these are your notes for Module 5 and 6, is be able to solve for missing angles of a triangle, okay? So if we take a look at our first example here, triangle JKM, okay? We also have two smaller triangles, JKL, and you'll notice JKL, we don't know, there are two unknowns there. So I can only solve for one unknown value at a time. So I don't want to start with triangle JKL. So let's look at triangle KLM. Okay, well, KLM has only one unknown, and the question is, what's the measure of angle 2 or angle M? So using our information that all triangles are 180 degrees, KLM. So that's going to be, so that's 57 degrees plus 71 degrees plus angle 2 will give me, or needs to equal, 180. And this we can solve. If I add 57 and 71, I get 128, plus the measure of angle 2 is equal to 180. And then to find the measure of angle 2, all I have to do is subtract 180 from, or I should say, I subtract 128 from 180, and so angle 2 is equal to 52 degrees. Okay, so now let's look at the smaller triangle JKL. I mentioned earlier that there are two unknowns here, and angle 2, unfortunately, although I've solved for that angle, it doesn't help me determine the measure of angle 1 or angle 3. There's no relationship between those angles. But what I do notice is that angle 1 and 57, those create a straight line. And again, we've previously learned that a straight line has a total of 180 degrees, or a supplementary. So to find the measure of angle 1, I'm just going to subtract 180. I'm going to subtract 57 from 180. And I get 123. Okay. So angle 1 is 123 degrees. And now that I have angle 1, now I can find the measure of angle 3, because 123 degrees plus 28 degrees plus angle 3 as a triangle all add to 180. So I'm going to do 123 plus 28, so that gives me 151. So to find the measure of angle 3, I'm going to subtract 151 from both sides. And I'm going to get angle 3 is equal to 29 degrees. So angle 3 is 29 degrees. Okay? Now, I'm sure some of you are thinking, do I really have to write this out as an equation? I know, can I just add the two angles together and subtract from 180? Sure you can, because that's exactly what I did. Do you have to write it out as an equation? No, of course not. But for some people, it's helpful to see how to set up the equation. Because if we're dealing with variables or algebraic expressions at any point, we will need to use an equation. So that's why I did it, but you're not required to do so. All right, so let's take a look at this next example here. A lot of numbers going on. All right. But take a look. First thing I'm going to ask myself is like, okay, is there any triangle where I have two of the angles given? Because if I have two of the angles given, then I know I can solve for the third. And that is going to be triangle XYZ. Okay. You'll notice I have angle Y is 58, angle Z is 65, so then I can find the measure of angle 7. 58 plus 65 is 123. So 180 minus 123, and that's 58 plus 65 gives me 123. So 180 minus 123 gives me 57. Okay, so this is 57 degrees. Okay. So now, from there, what can I now determine based on the fact that angle 7 is equal to 57 degrees? This is where you're going to have to remember some of the rules that we've previously learned. And that is vertical angles. What do we know about vertical angles? Well, vertical angles share a vertex but are opposites to one another. They are also congruent. Okay, so if angle 7 is 57 degrees, angle 5 is also 57 degrees. Okay, so now you can now solve for angle 4, because you have, so for triangle VXW, you have two of the angle measures, and so you can solve for number 4. So go ahead and solve for angle number 4. Okay, so for angle number 4, you should have gotten 56 degrees. Okay, and that's because when I do 57 plus 67, I get 124, and 180 minus 124 gives me 56. All right, so I have 56 degrees here, so we got that. Now we just have our final triangle, which is W, X, and Z. All right. And if you notice, I don't have any angles there that are indicated. But what I do see is that angle 9, 8, and 9 have those little arcs. And we need to remember, what do those little arcs represent, or what do they mean? What they mean is that 8 and 9 are congruent. Okay, so that's going to be helpful. So we don't know what the last two we don't know what angle 9 and 8 and 9 represent, but we know they're going to be the same number. Now, this may or may not be difficult to see, but if you'll notice, 6 and 7, angle 6 and 7, form a linear pair or a straight line. So that means angles 6 and 7 add to 180. So I know angle 7 is 57 degrees. So if I do 180 minus 57, I get 123. So that is the measure of angle 6, is 123. Now we know 8 and 9 are congruent. So any ideas on how you might be able to solve that? Again, we're working with a total of 180 degrees. So So the first thing I want to do is subtract 123, which I did up here. So I know that there are 57 degrees remaining in this triangle of WXZ. Okay, so if angle 6 is 123, that leaves only 57 degrees left to distribute between both angles 8 and 9 because they're both the same measurement. So to find out what 8 and 9 equal, because they're the same, I can do 57 divided by 2 because we have to distribute the remaining degrees left evenly. And because they're both the same measurement, 61.5, no, I'm sorry, I take that back. One moment, please. 57 divided by 2 is 28.5. Sorry about that. So yeah, so 57, the remaining number of degrees, divided by the 2 angles left, leaves me with 28.5 degrees each. Okay, now it's your turn. Take a look at this example here and see if you can solve for the measures of angles 1, 2, and 3. Okay, so first we're going to want to solve number 1 first, because in this bottom triangle I have 2 of my angle measures, so I can easily solve for the missing angle. So when I do 19 plus 41, I get 60 degrees. Okay, so that means with 180 degrees total, I subtract that, the 60 degrees that are there, that leaves angle 1 to be 120 degrees. So 120 plus 19 plus 41 is our total of 180. Now, what you needed to remember is that angle 2 is vertical to angle 1. So that means this angle is also 120. And with that information, I now can solve for angle 3. So 120 plus 38 gives me 158, and 180 minus 158 leaves me a remaining 22 degrees for angle 3. One of the most important things that we need to know about a triangle is the fact that all triangles have a total of 180 degrees. So all 3 angles, if I was to label my triangle ABC, okay, the triangle sum theorem states that when I add all 3 angles together, I will have a total of 180 degrees. Now, I'm going to explain why every triangle has 180 degrees. I'm not expecting you to I'm not going to test you on why a triangle has 180 degrees, but I want to show you because it might help you remember and understand the concept better. So the way they proved this is that they drew a parallel line and to the base of the triangle. Okay. Now we know parallel lines are equidistant, and we also know that, and we've previously learned that when we draw a transversal through 2 parallel lines, that there are special relationships between different angles when the lines are parallel. Okay, so if you remember, alternate interior angles are congruent. We know this. Okay, and so along my green transversal, angle A and the green angle adjacent to angle B will be congruent. if I extend side BC as a transversal as well, you'll notice that angle C is also alternate interior to that angle on the other side of angle B, and those are congruent. So what we have here along, and we know we've previously learned that a straight line has 180 degrees. So this, if I label this angle 1 and this is angle 2, we know that angle 1 plus angle B plus angle 2 equals 180 degrees because it is a straight line. And we know that angle A is congruent to angle 1 because those angles are alternate interior angles along two parallel lines. And we know that angle C is congruent to angle 2 because along the transversal BC, angle C and angle 2 are also alternate interior angles, so those are congruent. So if, let's say angle C is 90 degrees, then that means angle 2 is also 90 degrees, okay? And if, let's say angle B is 30 degrees. So if we look at this equation here, look at the straight line, if angle B is 30 and angle 2 is 90, that means angle 1 has to be 60 degrees because there is 180 degrees in a straight line. We've previously learned that. And because angle 1 and angle A are alternate interior angles, this is also 60 degrees. So this is how mathematicians have proven that all triangles must have a total of 180 degrees. Okay, so again, do I expect you to be able to explain this to me and prove it? No. But I wanted to show you how and why they were able, and how we know that triangles are 180 degrees. What you